Okay, so welcome back. We are going to be continuing and finishing our unit on stoichiometry. Last class we talked about the theoretical yield, and the theoretical yield is the amount of products that would be formed if your lab went perfectly, right? If there was no actual errors in the lab, a perfect lab has occurred, there was no waste, there was no human error, there was no error in measurement. It's every single ounce that could be formed has been formed. This is the theoretical yield. And remember, this is basically just math, right? And we did this yesterday. So if you need a refresher on it, go back, watch the video from yesterday. And now we're going to be looking at these two new things. So actual yield and percent yield. And it's kind of, you probably already, you've heard me say in the last video, actual yield. Sometimes I said experimental yield, right? Those words are interchangeable. So actual yield is what you actually got. Remember I said very rarely in a science lab do you have 100% efficiency, where what you theorized you would get, you get exactly that. Like that doesn't happen, right? Because there's always going to be some form of error that happens, and our measurement tools are not totally 100% precise. So this is what you actually get. So after we do the experiment, right, we mix our chemicals together, we form our products, and then we weigh those products. Whatever weight that scale, that digital scale says, that's your actual yield. So of course, we're measuring it in grams, and generally, the actual yield is going to be a smaller value than the theoretical yield, unless there was some big mistakes in how you were measuring your ingredients, your reactants. Your percent yield is just a mathematical comparison of the actual yield and the theoretical yield. So your percent yield is basically just your actual yield over your theoretical yield, whatever that ratio is, times 100%, converting it to a percent. And we'll get into this. So here we go. During a physical science 20 lab, 2 students collected their sample of precipitate, which were the products formed, and they've measured them and found the mass to be 45.63 grams. Okay, so they measured it to be 45.63 grams. What is this? Is this their actual yield, their theoretical yield, or their percent yields? Well, it's what they actually got, right? So they actually got measured 45.63 grams. And then they did some math, and in a perfect lab, if everything went totally according to plan, their yield should have been 49.88 grams. Which number is this? This is theoretical. This is if everything went perfectly. So how do we calculate the percent yield? Again, you take the actual and you're going to divide it by the theoretical, and then you're going to multiply this by 100%. So we're going to multiply this by 100%. And that's our percent yield. So let's do this in our calculator here. You have 45.63 grams. This is what you actually measured with your equipment in the lab. And you theorized that you should have gotten 49.88. Let's see how efficient they were. And remember, I talked about how percent yield is often used as a measurement tool to determine how precise you were, how accurate you were, how well you were doing the lab. So there we go, 0.91, etc. Multiply that by 100 to get our percent. And our percent yield for these 2 physical science students was 91 we want 4 sig figs? Sure. 91.48%. So they were 91.48% close to their theoretical yield. which means somewhere around 8.5% of their reactants theoretically disappeared somehow. Now, things don't magically disappear, so how could you explain that they only got 91.48% of what they should have? Measurement error, right? You know, they were looking at the beaker, at the meniscus in the beaker, and said, that looks like 50 milliliters. And was it? It was probably 49.6 or 50.4, right? They were making some estimates, and that, of course, affects your experiment and your percent yield. Your turn. So for those of you on YouTube, pause the video here and work out the solution for yourself. Those of you in chat with me, try this out, determine the actual theoretical and percent yields. We'll work it out, and when you return from YouTube with your answer, you can check your solution. See you in a second. So those of you coming back from YouTube, here's your solution. Actual yield 21.13 grams, theoretical yield 19.11, and after you do the work for your percent yield, you end up with 110.6%. Good. Here, we're going to have to do a little bit more calculations this time. So we are actually going to have to calculate our theoretical yield. Here's the question. If 71.42 grams of calcium chloride, so here's my calcium chloride, if 71.42 grams of it is produced in a lab, when 50.55 grams of calcium hydroxide, here's my calcium hydroxide, if 50.55 grams of this reacted with excess hydrochloric acid. So this is in excess. Well, this is really nice because remember yesterday, the first step that we had to do to calculate our theoretical yield was find which one was our limiting reagent. Here, we don't have to find which one's our limiting reagent because we already know. If hydrochloric acid is in excess, that means that calcium hydroxide is limiting. So we don't have to find which one is limiting. We know, they've told us. And then they want us to determine the actual yield, theoretical yield, and percent yield. Okay. Well, one of them is really, really easy. They're telling us that 50.55 grams of this reacted with excess this and formed 71.42 grams of calcium chloride. That means our actual yield, what we actually produced, was 71.42 grams. Like this is what we measured in the lab, right? So that's our actual yield. So we're done. That was easy. Now we need to do our theoretical yield. So here's where we do what we did yesterday. We take our limiting reactant. So we have 50.55 grams of calcium hydroxide. We take our limiting reaction and we use stoichiometry to determine how much calcium chloride we could produce in a perfect world if no scientist ever made mistakes. So here we go. First, we're going to get rid of our grams of calcium hydroxide using molar mass. And so we need to have the molar mass of calcium hydroxide. So now we need to use our periodic tables. Okay. So what are we finding here? Calcium hydroxide. So we need one calcium that has a molar mass of 40.08, and we have hydroxide, so we need to add, and it was OH2, I believe. Yeah, OH2, so we have 2 oxygens and 2 hydrogens. So here's our mass of oxygen, 16. So we are going to do 16 times 2, and we have 2 hydrogens. Hydrogen is 1.01 times 2. So the molar mass is 74.1. 74.1 grams with 3 sig figs. Okay. Now we have moles of calcium hydroxide. We need to convert it to calcium chloride. So we're going to use a mole to mole ratio here. So let's check. It was already pre-balanced for us. Yes, it was. Okay. So there's a 1 there and a 1 there. So we're going to convert it to moles of calcium chloride. So moles of calcium chloride, and we're going to eliminate our calcium hydroxide. There we go. Now that we have moles of calcium chloride, we're going to find grams again using molar mass one more time. So we need now the molar mass of calcium chloride. Here's our calcium, 40.08. Here's our chlorine, 35.45. We have 2 chlorines, right? So we're going to go 40.08 plus 2 times 35.45. And we're going to find the molar mass of this. So 40.08 plus 2 times 35.45. We want 4 sig figs here. So there's our molar mass. 4 sig figs would give us 111.0 grams. And there we go. Now we're going to work out our solution. And we had grams of calcium hydroxide that canceled out, moles of calcium hydroxide that canceled out, moles of calcium chloride that canceled out, leaving us with that. Throw this in your calculator. So 50.55 multiplied by 1 over 74.1 times 1 times 111 is 75. How many sig figs do we want? Three sig figs. This is limited by 3. So 75.7 grams of calcium chloride. And what is that? That's our theoretical yield. So our theoretical yield is 75.7 grams of calcium chloride. Now we have everything we need to calculate percent yield. Percent yield is actual yield over theoretical yield multiplied by 100%. So our actual yield was 71.42 grams. Our theoretical yield was 75.7 grams. And we multiply this by 100%. And let's do it. $71.42 divided by our previous answer multiplied by 100. Our answer should only have 3 significant digits, so our answer is 94.3%. And that is our percent yield. So the process is kind of similar, right? Theoretical yield, this is what we were doing yesterday. So you calculate your theoretical yield. You're given the actual yield, and you find your percent yield. So now it's your turn. Here's your question. If you're watching on YouTube, pause the video now and work it out. So for those of you coming back from YouTube, here's your solution. You were given the actual yield, 10.01 grams. You were told that calcium hydroxide was limiting. So you use that information that calcium hydroxide is limiting, do your stoichiometric calculations to find that the amount of H2O that could be produced is 3.96 grams. This is your theoretical yield. Now you take what you actually got, 10.01, divide that by your theoretical yield, and multiply by 100% to find that these two students somehow got 253% more materials, products than they should have. Begs to question, what in the world were they doing in the laboratory to get 2.5 times what they should have? We're going to do one more practice question here. This one's set up a little different. We're being asked to determine the actual yield of CCl4. So we're not given the actual yield this time. We're told that the percent yield is 55.8% when 99.99 grams of chlorine gas reacts. So we know 99.99 grams of Cl2 is reacting. How do we solve for this? Well, we need to first figure out which one's limiting, don't we? We don't really know that. So we need to do a little comparison here to find out what's limiting. So we're going to go grams and we're going to convert to moles of Cl2. Now chlorine, I believe, is 35.45. It is. So 35.45 times 2 is 70.9. All right, so now we have the moles of chlorine. Remember, when you're trying to determine the limiting reagent, you're comparing your two reactants, right? So it's already balanced for us here. Is it? Yeah, it is. And so we're going to convert to CS2, carbon sulfide, and we have 3 moles of Cl2. And now we need to have the mass. So carbon disulfur has a molar weight. Carbon is 12.01. And we have a disulfur, and each sulfur weighs 32.07. So 76.15. Of carbon disulfur. Okay. What do we got? 99.99 times 1 over 70.9 times 1/3 times 76.15. So we have 35 point, how many sig figs do I need? 3. 35.8 grams CS2. Actually, we don't know how much CS2 we started off with. So this is going to cause some problems because we don't know which one's limiting. We don't know which one's limiting, so we don't really have anything to compare this to. So I'm just going to modify the question. Since I'm making things up, let's make this 40 because I want to talk about what would happen in the other direction because I don't think we did a problem like this yesterday. So let's look at this. 35.8, which is what we found, is now less than 40.0 grams of CS2. So I don't think we encountered a situation like this yesterday. It always kind of worked out the other way. In this case, because we have 40 grams and we would only need 35.8, we have an excess amount of carbon disulfide now. So that's what that means. When your number is less than what the number you found is less than what you started with, it's excess. So now we can say this is excess and this is limiting. All right, so let's go back. We had 99.99 grams of chlorine. We are going to convert it. You can kind of probably see why I wanted to do that, because now I don't have to calculate a whole bunch of new molar masses. So moles of chlorine. And now we're going to go from moles of chlorine to, we want CCl4. So we're going here. So 1 mole of CCl4 over 3 moles of chlorine gas. And we only need 1 molar mass calculation now, CCl4. So carbon is 12.01. And we have 4 chlorines, and each chlorine is 35.45. So our molar mass is 153.81 grams. And let's calculate. 99.99 times 1 over 70.9 times 1/3 times 153.81 is 72.3. How many sig figs? 3 sig figs? Yep. There we go. Grams of CCl4. So here we go. We have 72.3 grams of CCl4. This is our theoretical yield. We need to now find the actual yield. So we have percent yield equals actual yield over theoretical yield times 100. This is kind of like a level 4 question, guys. So we now have our theoretical yield. We're given our percent yield. Here it is. And we're finding our actual yield. So let's plug that in. So percent yield is 55.8. 55.8% equals our actual yield, which we don't know, we're solving for that, divided by 72.3 times 100. Actually, I'll keep the percents in there. They're going to cancel out in a second. All right, we got to do some math here. Let's get rid of the 100%. How do we do that? You divide by 100%. So we have 55.8 divided by 100, which is 0.558. I'll do it in the calculator just so you can see. 55.8 divided by 100 is 0.558. And the percents are going to cancel out. So I'm going to take out this. These are gone. The percent signs are gone. We're left with 0.558. And on this side, we have actual yield divided by 72.3 grams. How do we isolate actual yield? Multiply by 72.3 grams to both sides. And then actual yield is going to be by itself because those cancel out. So you'll have your actual yield is equal to whatever that multiplication is. Let's figure that out. We have 0.558 multiplied by 72.3, and that is 40.3 grams. There is our solution. So it was a multi-stepper. Made a little bit more difficult because we weren't told whether it was limiting or excess, so we had to figure that out first, then calculate theoretical yield, then punch it into here and solve for our actual. So now it's your turn. I am going to edit this to make it a little easier for you guys. Determine the actual yield of S2CO2 if the percent yield is this when that much chlorine gas reacts, and I'm going to say with excess CS2. So now you do not need to do that calculation. You already know that chlorine gas is limiting. For those of you on YouTube, try this out. Come back in a second. So for those of you joining us from YouTube, we first used their limiting reactant of chlorine, did our stoichiometric calculations to find that the theoretical yield of sulfur chloride would be 35 grams. Using this, we plugged it into our percent yield formula. So we do not know the actual yield, 89.2%, which is what was given to us. 89.2% equals our unknown divided by 35 multiplied by 100. Then you isolate actual yield and find that the actual yield was 31.2 grams. So that's it for physical science for this unit. Calculating actual yield, theoretical yield, and percent yield. Hopefully you guys are feeling confident with this. Thanks for watching, everybody. You can like, follow, and subscribe to my social medias to get notifications as soon as new content is uploaded. In the top corner here, you will find the playlist that this video is in. Watch the unit from beginning to end, and over here, you will find the next video in this unit. Keep learning, everybody. Take care.